Okay, so as I said, some people have a little trouble with factoring. Other people aren't having that much trouble with factoring, just understanding that you've got a factor. Okay? And the assignment for tonight, the assignments coming up will kind of reinforce that. But if you're having trouble with factoring, if you can't pretty much immediately factor this, or at least if you can't factor it after some effort and get it right, then you need to upgrade your factor. Okay. So this first problem, so let's talk about two things. First of all, what happens when you factor, and second of all, how do you write down your solution? Okay. So we've got x minus 4. Let's say x plus divided by x squared minus 6x plus 8. Now, I intentionally set this up so with factor, because there's no way with A, B's, and C's, without going through a lot of arithmetic, that I can give you a randomized problem here. That I can do it on a test, just have control over how things come about. So there was a method to my madness when I did this. So that is factor. Numerator and denominator. Of course, the numerator is already factored. We don't have to do that. And then we write down what we get when we factor. We don't do the factoring here. This space is reserved for what we get when we do this. Okay. So this is x minus 4 times x plus 9. And this factors into x minus 2 times x minus 4. Okay. If you're doing anything else other than just writing down what you get when you write down the numerator, which doesn't have to be factored because it already is, and writing down the denominator after it's factored, do it off to the side someplace. Don't use this space. This space is reserved for something that's equivalent to this. And don't just factor the denominator right down here, write the whole thing down. Okay. That's important. Okay. Now, match up like factors. That means we write x minus 4 times x plus 9 over x minus 4 times x minus 2. So we can see that we have an x minus 4 divided by x minus 4. Okay, so we take this and we move it over here so it matches this. Then I say isolate the ones. If you've got like factors, then you got some ones. You got x minus 4 here, x minus 4 here. Okay, why is this the same as this? Because of the rule for multiplying fractions. If you multiply the numerators, you get x minus 4 and x plus 9. If you multiply the denominators, you get x minus 4 and x minus 2. Okay. Then I say isolate ones, I'm going to say isolate the like fact. So do this. And then calculate the one. That just means x minus 4 over x minus 4 is 1. I have more than one person tell me it was 0. Can you show me two numbers that you divide? Divide a number by itself and get 0? No. Any number, you try. 17 divided by 17 is 1. Any number divided by 1 by itself is 1. And x minus 4 represents whatever number you get when you plug in x. Whatever you plug in for x, this is going to be the same as this. It's going to give you 1. So this is 1. Times x plus 9 over x minus 2. And then multiply or divide by each one. Well, 1 times this just gives you x plus 9 over x minus 2. Those are the details. Now, open math might tell you just cross these out, but people want to cross out this one and this one. Okay, but you can't do what I did here with the x squareds over here. You can't factor out an x squared out of this, and you can't factor x squared out of this, so you can't match up an x squared over an x squared. You can only do that with factors because of the rules of multiplication of fractions, division of fractions. Okay. And as long as people are tending to do this, and they do it all the way through pre-calculus, I don't want to see cancellation. Okay. I want you to be sure that you understand. Now, one thing you got to understand is you can only do this again with factors. This factored out of here, this factored out of here. You can match up the factors. You can divide the factors, which gives you 1. Okay. Okay. Try to understand at the very least, you can't cancel out the x squared and the x squared. You can't cancel this x with this x. You can't divide this by 2 and divide this by 2. You can only multiply and divide numerator denominator by the same quantity. Okay. Okay, well, enough of that. Let's go ahead and do this one. We got now I'm going to follow the same steps. I'm not going to write out words, but you really want to make sure you've got a note there where you can say what you're doing in each step so you can reinforce what you're doing and think about why you're doing it. Okay. So we want to factor the numerator denominator. In this case, we can factor. Now I have to simply assume that you can factor. And everybody pretty much can, but you have to understand the distributive law in order to factor. And some of you can use a little brush up on it. Some of you are really good at it, and some of you are okay at it. It's taken a while. Okay. As I said, the homework you have is going to be heavy on factoring. So you're going to get plenty of practice. You know the basics, you know how to use distributive law. Okay. Okay, well, then this factors this way, this factors this way. How do you check your factoring? You multiply things out using the distributive law. X times x plus 9 plus 2 times x plus 9. Which does come down to you multiply this by this, this by this, this by this, this by this. For binomial. What do we do now? Well, I want you to show me the next step. Don't bother writing everything down at this point. Just write out what I should put down here for the next step. Okay, we're a little hung up on a couple of things, but I think we're making good progress here. So everybody, okay, two things. I still see people writing this here and this over here and this over here on the cave wall or whatever, okay? And scattering the work all over the place and not following the logical projection. Logical procedure. The advantage of writing it down this way is you see what follows from everything. If you've got to do a little work to factor this and some figuring off to the side, do it over there. Okay. Leave yourself room to do the figuring over here and just write expressions over here. Otherwise, if you lose track of what you're doing and you don't reinforce it for yourself quite as well. Okay, so in this case, we got the X plus 2s actually matched up. So that, you know, this really is pretty much like the third step, right? Okay, but if you're gonna write out the third step, in general, things that match up are not immediately one over the other, okay? So we can go on to this step. And we can write this as X plus 2 over X plus 2 times X plus 9 over X plus 2. And the advantage to that, first of all, why does that work? Again, it's because if you multiply these numerators, you get X plus 2 times X plus 9, which is exactly what you have up here. And if you multiply the denominator, you got X plus 2 times X plus 2. It's very clear that this multiplies out to give you this, but now X plus 2 over X plus 2 is sitting here smiling at you because it knows that you know that it's going to be 1. Okay, so that's 1 times X plus 9 over X plus 2, which is X plus 9 over X plus 2. All right, well, we have to move on. We have to use factoring, and you got 3 assignments coming up for next time. And all 3 assignments use exactly the same steps that you use when you add and subtract fractions or multiply fractions. So let me just give you an example. Let's say we've got okay. What are you going to do with that? What do you do when you have 2 fractions? How do you add them? And we'll turn the, come on. Okay, it just, just right down here. What 5 9s plus 3 9s? Okay, don't say it. But tell me, what's the numerator going to be? Show me your fingers. And everybody got it, right? And that's 5 plus 3 over 9, same denominator. Okay, which is 8 over 9. Operationally, and the common sense is you got 9s. You got 5 of them, you got 3 of them. If you got 5 oranges and 5 apples and 3 apples, you got 8 apples. If you got 5 9s and 3 9s, you got 8 9s. If you got 5 of something and 3 of something, you got 8 of that. Okay. And this is the way that works out with the rule. If you have the same denominator, you're going to be able to do that. Okay. Well, here we have the same denominator. So what did we do here? We added the numerators. What are we going to do here? We're going to add the numerators. Okay, so that's okay. Now it's x minus 7. You got an x minus 7 and an x minus 7, but you're not multiplying anymore. You want to get your head out of the multiplication mode, even though we've been hammering away on that here, because everything you've seen so far is multiplied. That's not the case there, it's added. So we're shifting gears. And you got to pay attention to when you're adding, multiplying, and all that stuff. Okay. Anyhow, if we do this, we see that that's 2x plus 2 over x minus 7. Now, some people got the 2, so I know they were doing the right thing, but didn't notice that you have 2 x's here, right? X plus x is, you got an x, you got an x, you got 2. Okay. Now, what do you have? What are you going to do if you have x plus 4 over x minus 7 plus x minus 2 over x plus 5? Well, you can think, what do I do if I have fractions with unlike denominators? I'm going to leave this here. Because we all understand that. What if it was 5/9 plus 3/4? What do we do? Okay. Well, let's discuss it real quickly. Okay, so what we do here, what I asked, so you multiply the 9 by the 4, and you don't because it's addition, but you do because 9 times 4 is going to be your common denominator. You don't really multiply. Okay, you just write it out as 9 times 4. Because that's what it's going to turn out when you do what we do, which is to get 9 times 4 in the denominator, we've got 9 here, we need to multiply it by 4. And you can't just multiply the 9 by 4, you change the value of the fraction. You've got to multiply both the numerator and denominator by 4. Because in that case, you're just multiplying by 1. There's that whole idea again, if you divide a number by itself, it's 1. And multiplying something by 1 doesn't change it. It might change the way it looks. Okay, it doesn't change its value. And then we have our 3/4. Which we multiply by 9 divided by 9. Okay, now by analogy, what are we going to do here? Okay. Some people did a good job of getting this stuff. Mostly had a little trouble with it. So we want to have the same denominator. So we would note, and I didn't leave myself room to note it, I run the range. Now your common denominator is going to be x minus 7 times x plus 5. But some people just wanted then to multiply out x minus 7 and x plus 5 and make that the denominator, and then maybe add numerators or something. You can't do that because if you make the denominator x minus 7 times x plus 5 and don't change the numerators, it's not going to be equal. Okay. What you need to do to get the common denominator is you need to multiply both the numerator and denominator by the same thing to make the denominators the same without changing the value of the fraction. Okay. You just multiply the denominators and don't have to do anything to the numerators, you've changed everything. It just doesn't change anything, just like this didn't change anything. Didn't change the value, changed the way it looks, it didn't change the value. Any number you put in for X here, put in the same number for X here, you're going to get exactly the same thing. Now you might have to reduce it when you do this. It's going to have exactly the same value. Okay. Then you have X minus 2 over X plus 5 multiplied by X minus 7 over X minus 7. Because again, you're just multiplying by 1. And what's that equal? Well, we're going to leave the denominator factor. You have the same denominator. So we can add the numerators. Now I'm going to write it all out. X plus 4 and X plus 5 added to X minus 2 times X minus 7. What's that equal? Well, X plus 4 times X plus 5, you want to use a distributive law. But that's X squared plus 9X plus 20. And then X minus 2 times X minus 7 is X squared minus 9X plus 14 divided by X minus 7 times X plus 5. And now we're running out of room. I'm going to borrow the room and use it over here. I'm going to take it back. I have room to write out the final result. In the numerator, I've got 2x squared, right? So that's x squared, 2x squared, almost there. Okay, 9x and minus 9x is 0. Write out the 0, right? You really don't want that. And then it's plus 34. All that divided by X minus 7 times X plus 5. Then, if possible, you factor the numerator. But the numerator isn't going to factor because this numerator is never 0. Okay, this is positive, this is always positive, and you don't have anything here to match up, so you're not going to be able to factor. On the final step, since you can't factor the numerator, and open math is going to coach you on that. You got this, then you got x squared minus 2x minus 35. Okay. Now it all comes down to this. You do what's necessary to get the common denominator without changing the value of things. So you got to multiply numerator and denominator by the same number on each of these fractions, or by the same expression. Just like you did when you added fractions with numbers. Okay? So there it is. Let me give you another example. Try to follow the steps in this problem exactly as I did them here. What's the first thing I did? I made myself a note. It's a common denominator, right? Okay. Now there's something about the common denominator you're probably going to miss. That's okay, we'll fix it. And if you happen to notice it. That'll be great. Okay, but what's a common denominator? Find a common denominator and then execute this step where we multiply numerators and denominators. Place same number. Okay, we're almost out of time, so I'm going to have to go on with this. Imitate the solution you see. What did I do in the solution? First thing, I did pointed out with, I wrote out what the common denominator was, okay? Now you always get a common denominator if you just multiply the denominators. When we had 5 nines plus 3/4, we knew that the denominator, common denominator, is going to be 9 times 4, because those are the denominators. When we did this, we saw denominator, denominator, so the common denominator is this times this. Okay. Now there's also least common denominator, and you're going to have to let open math work you through that a little bit, but it's not too bad. And I'll try to illustrate it in the time we have. But you want to write out what the common denominator is. And you can always write it as the product of the denominators. Now I'm going to show you in a minute, we could write an easier common denominator. This is then going to be this fraction is going to be written this way, and now its denominator is going to be x plus 2 times x squared plus 6x plus 8. Then we're going to have we get the same denominator. Well, we've got x squared plus 6x plus 8. If we want this, we better multiply by x plus 2. We can't just multiply the denominator by x plus 2. We've got to multiply both numerator and denominator by x plus 2. Okay, well, I'm not going to go on with this because it gets a little easier. If you see something like this, you always want to factor. You always want to reduce everything to the factored form. Okay. So we have this thing factors. I used it and I used it before, so it'll be obvious how it factors. Okay. So now I see this. What's my common denominator? So my common denominator, it's got to have this denominator. It's got to have an x plus 2, and it's got to have an x plus 4. Okay. And it's got to have an x plus 2, but it's already got an x plus 2 because you got the x plus 2 in this one. Okay. So we have a simpler common denominator. We don't have to multiply by quadratic over quadratic because this quadratic factors, and one of its factors matches this. So all we have to do is multiply by Okay. And we don't need to do that. And where we're at the end of the class, actually we're at it. Okay. We don't have to multiply by the whole denominator. We need to get a denominator of x plus 2 times x plus 4. All we need to multiply the denominator here by is x plus 4. Because then we'll have x plus 2 times x plus 4. We'll have a common denominator. And of course, to multiply the denominator by x plus 4, we've got to multiply the numerator by x plus 4. Then we have this. What do we need to do to get the common denominator here? I don't want to take too much time because we're out of it. We already have the common denominator. We don't have to do a thing to this. So now this equals if we now have the same denominator, we just multiply out the numerator here, we get this, and we add this, which is going to be this plus this over this. And when that's the procedure, it's critically dependent on factoring things. And then understanding how you add, subtract, multiply, and divide fractions. Now, I haven't even talked about multiplying and dividing fractions because that's easy. I think you already have the skills to do that. So I think those two assignments will be fairly straightforward. The third one that you have between now and next time is adding and subtracting fractions, and that is the one that's more challenging. You need to do the first two so you get used to the factoring. And if you know how to do the factoring, they're not difficult. If you don't know how to do the factoring, if you're a little slow on it, it'll make you faster. Then we apply it, adding, subtracting fractions. Okay. So I think you're in shape to do this. Not sure I recorded that, but I'll record it again if necessary before my next class comes in. Again, I think people are in pretty good shape to build their factoring skills and then apply them to adding and subtracting rational functions, rational expressions. Okay, I'm not sure I recorded what I wanted to record. But here's what we can do with this common denominator. We want to get common denominator of x plus 2 times x squared plus 6x plus 8. So we have to multiply the x plus 2 here by an x squared plus 6x plus 8. We can't do that unless we also multiply the numerator by x squared plus 6x plus 8. So we get here, what we're missing in the common denominator here is the x plus 2. So we multiply by x plus 2 over x plus 2. And everything can work out, except it's messier than it needs to be. The reason for that is, well, what we really want to do is we want to reduce every numerator and denominator to factored form. Okay, so factored form of this is x plus 2 times x plus 4. We saw this in an earlier example. So we know that we can factor this. It's easy to factor. We get this. So we replace this by this. This will stay the same because everything's already factored. And then we identify that our common denominator in this case is what? Well, we have to have x plus 2 and we have to have x plus 4 in our denominator. Okay, we also need x plus 2 in our denominator, but we've already got it. We don't need it again. So we have a common denominator now that's simpler than the quadratic expression that we had previously. Okay, the product of the linear and quadratic expression. Okay, this is a simpler common denominator than this. This is our least common denominator. Okay, so to get that denominator, we've got x plus 2 as a denominator here. We need an x plus 4. So we've got to get x plus 2 times x plus 4. Well, we can do that. We take this fraction and we multiply the denominator by x plus 4. Now we have our common denominator. But we also have to multiply the numerator by x plus 4. Otherwise, we change the value. So again, we multiply by x plus 4 or x plus 4. It's going to give us a common denominator of x plus 2 times x plus 4. And then here, what do we need to do to get our common denominator? Well, we've already got it. We don't have to do a darn thing to this. Much simpler than what we'd have done if we hadn't realized that this three factors. Okay, well, then we simply do what we do. The numerator of this fraction is going to be this times this times this. The denominator is going to be this times this. The denominator is going to match the denominator of this. So we do this times this times this, where it is added to the numerator here. Now there's more to do. You've got to use a distributive law a couple of times to multiply this out. Unfortunately, we had to spend a lot of time on some real basic stuff, and it was important to do that. I think we have it in shape to where if you do the assignments carefully, you'll be able to do them. You have to multiply and divide fractions. That's pretty easy. You know how to reduce them, which is the first thing we talked about here, but that was an assignment for last time. And everybody seems to be in shape with the just factor things. It works out. Okay. For multiplying and dividing, that becomes fairly easy. Adding and subtracting, which is what we concentrated on here, is the more difficult and more challenging task. And it's really good. I mean, if you can do this, you really know some pretty good intermediate algebra. Okay. It's one of the harder things in intermediate algebra. So a lot of assignments due for next time, but they're all based on factoring, which was our last assignment. So get your factoring skills up and move on.